doubles. Simulation, but how long it take a middle value. See, there are two possibilities. Either it's up or down. Okay. So why don't we increase the activity? But you are getting there. We have to talk to sir. I can't tell you what's going on. Because telling that you are getting a bed there. That is what. Okay. And 5 lakh, 500. You are writing here 30,000. Activity 0.006 or something. So sample run right at every 500. What I'm saying is, there might be a step where this flow might come and go quickly. It is a speculation. I'm not saying that it will happen. Or increase the activity for the 0.002 to 0.003, you are getting closer. Actually, same thing happening with 0.03 also. Correct. So take a activity of 0.0025. And check whether you get it. Either secondly you get a error. Okay. Check whether you get it. Take that. Yeah. Try telling you might say but for 0.002 and other where you actually get close. Let's say 0.002 and 40 60. Observation that you need to make. So now we check for how many flows you get made. You get made. It does look like bed.
Power on.
So, and for this one, you are getting split. So, it might be a possibility that here is this is the limit, and you are getting bend there. If you are increasing the activity, the bend is breaking down. If you are getting turbulence. Tell him that you are getting bend information. And then you provide it over there. But that is
Okay, let's get started with today's session. Welcome to the live session on fluid and particle mechanics offered on NPTEL by Professor Sumesh Thampi and Professor Basavaraj. I'm Shankar. I am your teaching assistant. This live session is on Mondays from 6 o'clock to 8 o'clock in the evening. If you have any doubts, please feel free to come to these interactive sessions and post your questions here. Alternatively, you can also do it on the Ask a Question forum available on the website on the SWAYAM website. So let's get started. We will do some practice problems as well as assignments and some extra questions. We'll start with the previous week's assignment, which is based on fluidization and cake filtration, etc. So let's do the first question. This is the solved. This is the graded assignments that were available on NPTEL before. So let's get started. A packed bed of solids of density 2 gram per centimeter cube occupies a depth of 120 centimeters in a cylindrical vessel of diameter 10 centimeter. The mass of solids in the bed is 10 kilogram and the mean diameter of the particles is 0.3 millimeter. Water flows upwards through the bed. What is the voidage of the packed bed? So we need to understand what this term voidage means, and we know that it is the volume of uh, free space divided by volume of uh, the column or the vessel, and this is 1 minus the volume of solids by the volume of vessel. So we can find it using this simple formula what the voidage would be. And for finding the volume of solids, we have a simple formula which is given by the mass times, or sorry, the weight of solids to the density of solids. And the weight of solids is uh, given as 10 kilogram, and the density of solids is given as 2 gram per centimeter cube, which is 2000 in the SI units, kilogram per meter cube. So let's take a look at the question. There is a packed bed and there are some solids in it, and these solids are they have a diameter of roughly 0.3 millimeter. These are in a vessel of diameter 10 centimeter at a depth of 120 centimeters, and we know that the fluid that comes out is water. Yeah. So based on this simple formula for the volume of solids, we know that the weight of solids is 10 kilogram and the density of solid is 2000 kilogram per meter cube. Therefore, the volume of solids will be 10 by 2000, which is 0.005 meter cube. Okay, so let's move on to what the volume of vessel is. We know that it is a cylindrical vessel as given in the question, and therefore we can just use the equation for calculation of the volume of a cylinder to find the volume of this vessel. The diameter of the vessel is given to be 10 centimeters and the height is given to be 120 centimeters. So converting that to meters, it would be 0.1 meter here. This would be 1.2 meter. So performing a simple calculation, pi times 0.1 square by 4 times 1.2. We get the volume of the vessel as 0.00942 in the SI units. Therefore, we can calculate the void edge, which is given by epsilon as 1 minus 0.005 divided by 0.00942. Yeah, it is just a substitution of this equation over here into the value of epsilon, that is the void edge, and you will get this as 0.53. Okay, let's move on to the next question. Now the set of first part of the paragraph remains the same, where you have packed bed of solids, and now we are required to calculate the superficial liquid velocity, in which the pressure drop across the bed is 8260 Pascal. So for this we use the Ergun equation, which is given here as delta P by L is equal to 150 mu into 1 minus epsilon square into V bar naught by epsilon cube dp square plus 1.75 into 1 minus epsilon times rho V naught bar square divided by epsilon cube dp. Now this is known as the Ergun equation. Yeah, I just noted it down over here as well. This is a simple direct substitution of whatever you found till now over here. You just have to solve for V bar. So it is given that the pressure drop across the bed is 8260 and L refers to the depth or the height of the cylindrical vessel. So let's write everything down. Here delta P is 8260 Pascal. L is the height, which is 1.2 meter. Viscosity is of the fluid, which is 0.001 Pascal second. And epsilon we just found out to be equal to 0.53. And density of the fluid is 1000 kilogram per meter cube since it is water. And the diameter of the particles is 0.3 millimeters, which is 0.0003 meters. What we have to do is substitute here, which is done as follows. So I'll substitute along with the unit so that there is no confusion. This is in Pascal. 1.2 meters is equal to 150 into 10 raised to minus 3 Pascal second times 1 minus 0.53 square V bar naught divided by epsilon is 0.53 cube times dp is 0.0003 square plus 1.75 times 1 minus 0.53 times 1000 kilogram per meter cube times V bar naught square divided by epsilon cube times dp. Now we just have to solve this quadratic equation in terms of V bar naught. Here V bar naught I have defined this as the V bar naught is the superficial velocity. This is finally get V bar naught as 2.7 into 10 raised to minus 3 in SI unit, and the answer has to be reported in millimeters per second, so that would be 2.7 millimeters per second. Okay, I think I've made a small mistake over here in the fact that epsilon is not 0.53. So it is in fact, as we saw earlier, it is in fact 0.47. Therefore, when we make the changes here, we'll have to do it as 0.47. Therefore, these numbers will automatically change. I'll be writing the numbers soon. Please see if we are able to calculate and get the same values that I'm going to get right now. You get the final velocity as 1.51 into 10 raised to minus 3 meter per second, which will be 1.51 millimeters per second. Yeah, sorry for the error. I hope you find the correct answer convenient. Okay, we'll move on to the next question now. And corresponding to these conditions which was discussed earlier, what is the actual velocity of the fluid flowing through the bacteria? Please note that this was the superficial velocity, which has to be denoted with an S subscript, which I have not done here, and I have accounted it for here now. Therefore, the actual velocity given by V naught is equal to V naught S by epsilon. Therefore, this value epsilon is the void edge, V naught S will be the superficial velocity, which is 1.51 millimeter per second divided by 0.47. And yeah, you can calculate this value. It will be 3.2 millimeter per second. This will be the actual velocity. You should always know that the actual velocity will always be more than the superficial velocity. So yeah, this answer would be correct. Okay, let's move on to question number 4. A leaf filter has an area of 1.73 meters square and operates at a constant pressure drop of 300 kilopascal. And the following results are obtained during a test run on a filtration of a slurry. Assume the cake is incompressible, and this is the time volume as a function of time data that is given in this table. And we have to first evaluate the slope and intercept required for the calculation of specific gate resistance and filter medium resistance. So first let's find out the slope, which is basically the 2-point formula, which is V2 minus V1 by T2 minus T1. You can take any V and any T for the calculation here. I'll show with both. I'll show with two different. Let us take first time difference of 5 and 10, and also with 5 and 30. So V2 minus V1, the 5 and 10 case would be 0.31 minus 0.19 divided by, this is in meter cube, divided by time in minutes, which is 10 minus 5 times 60 in seconds. If we are using the last, the first and the last point, we'll get 0.63 minus 0.19 divided by 30 minus 5 times 60. In the first case, you'll get a slope of 0.0004, and in the second case, you'll get a slope of 0.000293, which is not very far, but you can give the slope value anywhere in between these two. And if you have to evaluate the intercepts, you just take a point or a data sets like 5 and 19 or 15 or 10 and 21. Take one data x and y or one v and t, and then substitute the value of the slope over there. We'll stick with this value of slope for now, where 0.0004 is given. So it is given that 0.19 meter cube is calculated as the y, and the slope is 0.0004 times the time value, which is 5 into 60 seconds, plus the intercept, which is the y equal to mx plus c formula, that is the slope intercept form. And the intercept will come out to be 0.007. The slope will have the unit of meter cube per second, whereas the intercept will have the unit of volume. It's okay. Okay, we move on to the next question. And we just need to calculate the time required to collect 1 meter cube of the filtrate of the same slurry at the constant pressure drop of 400 kilopascal. And we have to report the answer in minutes. Okay, there were a couple of mistakes, and I wish to redo this problem. We have to evaluate the slope and intercept that is required for this calculation of specific cake resistance and filter medium resistance. So we have to plot a function of T by V versus V, and let us convert the data into T by V versus V, where the time and volume is given as follows. And time is given in minutes and volume is given in meter cube. So we have to plot T by V, and you have to plot that in seconds per meter cube so that it remains in SI units. So I think I made a mistake here. I'm just redoing this along with you right now. So now if we take the 2-point formula, we'll be getting it as follows. Like if I have to take a slope, I'll get it as, let's take the first 2 points here for calculation of slope, and we'll get that as 1935.4 minus 1578.9 divided by 0.31 minus 0.19, and I'll get this answer as 2970.8. Now if I have to calculate the intercept, I'll have to again just do the math over there, is equal to T by V minus V times slope, and just have to substitute some particular value of T by V and corresponding value of V. Let me take the first point, so I'll get it as 1578.9 minus 0.19 times 2970.8. Which will come out to be 1014.4. So yeah, these are the values that I get for the slope and the intercept while calculating the specific cake resistance and filter medium resistance. Okay. Okay, we will move on to the next question, where we were supposed to calculate the time required to collect 1 meter cube of filtrate during filtration of the same slurry at a constant pressure drop of 400 kilopascal. You have to report the answer in minutes. You know that it is given as a constant pressure drop, which means it is a constant pressure filtration, and this is the formula that is associated with that, which is T by V as plotted as a function of V. We get the slope and the intercept. We'll calculate various values like RC phi mu and V equilibrium or VEQ, and then we find out the volume it required to get the 1 meter cube of the sample. Now let's do it together. So um, we know that the slope, sorry about that, yeah, we know that the slope has a value of, let's, 2970.8, and this is equal to RC times phi times mu divided by 2a square delta p, and the area is given. These terms have been explained, I'm sure, in the lectures that have been there, that are there on the NPTEL. So the area is given by 1.73 meters square. The pressure drop is given as 400 kilopascal, and based on this information we can calculate what is RC times phi times mu. We'll get it as 2.055 into 10 raised to 9. In the SI units. So, sorry, this times 2, so this will be 4.11. Yeah, sorry about that. This would be 4.11 times. Oh, just 1 second. I think I'm making a couple of more mistakes here. Since I'm doing it along with you, I think I'm also involved in a couple of mistakes here. This would be a square, so 7.113 into 10 raised to 9 in SI units. Here RC is a specific cake resistance, and all the other terms have been explained in the class. Okay, then what do we have? We just have to find the intercept now, or find VEQ from the intercept. We know that the intercept has a value that we found out earlier to be equal to 1014.4, and that is equal to RC phi mu by a square delta p times VEQ. And from here we can find out this VEQ because we know the values of RC phi mu by a square delta p. So let me just calculate the value for you. So from here we'll get VU EQ as 0.1707. Yeah, it's still not over. We have just the uh, values now. Actually, we don't even have to do any of this. Now that I think about it, we can just substitute the time t as to be to found out for the time required for the collection of 1 meter cube as the slope 2970.4 or sorry 0.8 times 1 meter cube plus the intercept that is 1014.4. And we'll get that as 6.64 hours. Yeah, so I think again I don't think I made a mistake, but I'll just rewrite it. So if you are plotting the final equation as t by v as a function of v, you will get it as 7.113 into 10 raised to 9 upon 2 times 1.73 square times 400 into 10 raised to 3 times v plus 7.113 into 10 raised to 9 by 1.73 square times 400 into 10 raised to 3 times 0.1707. And if you substitute for v equal to 1 meter cube, you'll get the time in seconds to be equal to roughly 3985.2 seconds, and in minutes I'm getting it as 66.4 minutes. I think this answer is not matching with the answer that's given in the portal or the NPTEL website. I think I may have made a mistake somewhere. I'm not sure what I have done wrong, but if I get to know the right answer, I'll immediately share this with you. Okay, let's move on to the next question. Before that, I'll just give you a minute to read the question and try to think of it on your own. The next question is a bed of ion exchange beads that is 244 centimeter deep to be backwashed with water to remove the dirt. Particles have density of 1.24 gram per centimeter cube, average size of 1.1 meters. We have to figure out the minimum fluidization velocity using water, assuming water to be 1 gram per centimeter cube dense and the viscosity of water to be 0.001 pascal second, and the beads to be spherical and the porosity at incipient fluidization can be taken as 0.4. So I'll give you a minute to think about it. We know that it has to do with the famous Ergun equation, and we just need to figure out how to do it. I'll give you a couple of minutes to think about it before I give you the solution. Okay, so it's basically very straightforward. There's nothing to do here. All we have to do is find delta p by L. Rest all values are given in the question. So let's write down what is given. The viscosity is 0.001 Pascal second. Epsilon, that is the incipient, uh, the porosity at incipient fluidization is 0.4. The sphericity is assumed to be 1. The particle diameter is given as 1.1 millimeter, which is 0.0011 meter. Next, we also have the density of the fluid, which is 1000 kilogram per meter cube. And yeah, I think that's all what is required to solve in the Ergun equation. All you have to understand is the pressure drop has to be calculated as uh, pressure drop in total. Excuse me. Pressure drop has to be calculated as rho gh, that is rho p minus rho times g times L. Here rho p is assumed to or is given as 1.24 gram per centimeter cube, which is 1240 kilogram per meter cube. Therefore, if you find the pressure drop per unit length, you can just need to find out rho p minus rho times g, which is in fact coming out to be 240 times 9.81. Yeah, you'll get this value as 2354.4 in pascals per meter. Now we just have to substitute and find out the values for the velocity. That's all we have to do. So yeah. Yeah, we just need to solve this equation. and we'll get the velocity as 0.0104 meters per second. So I think I'll stop here. We have a lot of practice problems as well that I was planning to solve, but because of the time, I think I'll stop here. And if you have any doubts, please let me know. So yeah, we'll just do a couple of, this first part of the practice problems from week 8 is basically the same as what we have discussed here, where we have to plot T by V versus V. The only thing is that the data set has changed, so you can find out the answer here. The intercept, from the intercept, we just have to specify the specific cake resistance that also can be found out by RC5 mu. And yeah, that's all you have to do over there. Now let's move on to this match the following question that has been given, where we just have to find what matches with what. So where is Ergun equation used is basically what has been asked, and Ergun equation is used in for a packed bed. So A3 would be the correct answer. Now, where is Hagen-Poiseuille used? Hagen-Poiseuille is used for a laminar flow through a tube. Therefore, the correct answer is option 1. And Bernoulli equation Bernoulli equation is basically an overall energy balance equation, and we can use that over there. And the Stokes law is basically a settling regime, or it's for a particle that is settling in a viscous fluid. That for the correct answer is D6. There is no equation that is given in column A for a cross flow filter or a sphericity as it is. Now, this question does not make sense because if the dust were allowed to settle in a large rectangular chamber with a depth of 1 millimeter, what residence time would be needed to get complete dust removal? This question does not make sense because this question does not have any valid solutions here. So I think with that, we still have the week 7 questions to solve, but yeah, I think I'll stop here. I sincerely thank you for your time and attention. If you have any questions, please feel free to let me know by coming to the class or asking on the forum on NPTEL. Thank you.